Okay, question 1, compare the two functions here. F of 1 is an equation, so replace that x as 1 and do some mental arithmetic. So 2 times 1 plus 4 gives me a value of 6. So I'm comparing the value of 6 to g of 1. For g of 1, I go to x equals 1, find my graph. My graph is located right there. That location is 1, 2. So when x is 1, it's at 2, and now I can compare 6 is greater than 2. For the slope of the graph, the slope of the function that is an equation. The slope is again the number right in front of x, which is 2. For the slope for the other one, it is negative. Negative something I don't know, nor do I really care. If I know it's negative, a positive is greater than a negative. Now if I actually want to find it out, prize overrun. Okay, these are two nice points that I just identified. Down 2 over 1. Slope is negative 2. So, there we go. The y-intercept of f is 4. And the y-intercept of the graph is where it's crossing the y-axis at also 4. And then right there, they are equal to one another. Number 2 is the exact same thing, but now we are in table form. So f of 32, okay? F of 32, so when x is 32, I get a y value of 24. And for the other one, I gotta go to my calculator, a little bit larger to maybe do in your head. So negative 4 times 32, okay, give me a second. Negative 4 times 32 is negative 128. And then negative 128 minus 16 gives me negative 144. So in this case, 24 is positive. That is greater than a negative. For the slope, I do need to calculate right here the change in y's and the change in x's like we've done before. So positive 8, okay, whatever, is 16. So it's increasing by 8 over 16, which is a half. Comparing that half to the slope of g, the slope of g is the number in front of x, which in this case is negative 4. Positive 1/2 compared to a negative 4, 1/2 is greater than. The y-intercept from a table for the umpteenth time occurs when x is 0. That is my y-intercept. From the equation on g, the y-intercept is that other number, which is negative 16. Compare it. Positive is greater than a negative. Number 3, as we distribute the negative 2 to put it into the general form. We've been doing that a lot since first semester. Combine like terms. Watch your arithmetic. Negative 15 plus 2 is a negative 13. Number 4, letter A. Plug in that negative 1. 20 times negative 1 is negative 20. Minus 5 is negative 25. Now for part B, set that equal to one another and then do a little bit of math to find it out. It's a negative 5. The inverse of a negative 5 is a plus 5. Divide both parts by 20, and 10 divided by 20 is a half. So x equals a half there. Number 5. Gotta know the slope, gotta know the y-intercept to write the function. The slope is easy enough to find. Tell me how we are moving from point to point. Make those steps. And we can see up 1 over 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So the slope is just 1. 1x. The y-intercept is right up there at 4. So 1x plus 4. When I say f of negative 2, that means go to the x-axis at negative 2, find that location. That location is at negative 2, 2. And when it says 3, that means go to the y value of 3. Y value of 3 is right here. There is my graph. And that is located at negative 1, 3. So in order to get a y value of 3, the x value had to be negative 1. Do we have ourselves a linear function here? Okay. So I'm gonna pause actually and upload what I got.